Now let us see this problem. A thin uniform rod is pivoted at O, is rotating in the horizontal plane with constant angular speed omega, right? Now this is a rod and this is rotating with the speed omega as shown in the figure. At t equal to 0, a small insect starts from O and moves with a constant speed v with respect to the rod towards the other end, right? If this point is O, let us assume that this point is P, right? It reaches the end at t equal to t, at t equal to capital T, right, and stops. The angular speed of the system remains omega throughout. So that means it is remaining constant. Omega is remaining constant. The magnitude of the torque on the system about O as a function of time is best represented by. Now we have to find which of the curve represents it the best, right? Now if you see the problem, what is happening? This insect is moving. Let us assume at any time t it is at a distance x from O, from the center O, right? If it is at a distance x, what is happening? Why will omega change? It will change because angular momentum L will change, right? L will change. So at any time t, L will be equal to I into omega, right? Omega is constant, but I is changing. Why? Because I is equals to moment of inertia of the rod plus I of the insect, right? Now I of the rod will be constant. We need not worry about the value what it is giving because it is constant. Rod is not moving. Rod is just rotating about the axis. But insect, since it is moving outwards, I will change, right? If it is at a distance x from O, what will be I? I of the insect, that will be equal to, if the mass of the insect is m, right? If it is at a distance x, then it will be mx square, right? That means I will be equal to I rod plus mx square, right? That means L will be equal to I rod plus mx square into omega, right? Now torque is given by dl by dt. Torque tau is given by dl by dt, magnitude of this torque. This will be equal to what? D by dt of I rod plus mx square into omega. Now omega is constant. So di by dt of rod, since I is constant, this will become 0. So the only thing left will be omega we can take out. This will be m will be constant into 2x if we differentiate this thing into dx by dt. Right. Now dx by dt is given to us as what? This is the velocity of the insect. Because it is constant, it moves constant speed x. So that means this will be equal to m into omega into 2x into v, right? Now m is constant, mass of the insect will be constant, omega is constant, it is given in the question, v is constant, but x, it is changing with time, right? If we see, we have to plot torque tau versus time t, right? So we need t over here, right? If we see, since it is moving with a constant velocity v, we can very well write that x will be equal to v into t, right? X will be equal to v into t. That means torque tau will be equal to m into omega into v into 2 into v into t. That means torque tau is directly proportional to t. Is this correct? So that means obviously C option is not there because it is going in a curve, and D option is also not there. Now we have to choose between A and B, right? Now till the time t it reaches this point, it is having, right, it is linearly increasing with time t. But when this insect goes out of the rod, it does not have any link with the system now. So that means when we are rotating this rod with an omega, we do not require any kind of torque. This torque should not be constant, rather it should be 0, right? So that means option B will be correct.